All right, we will be starting soon. Please stick around. And we will begin with question number 31 from the previous test. Well, the test we were working on previously. All right, welcome back. So, as I have already said, today we are finishing up the final 30 problems from the test that we started last time. These are going to be the hardest problems from the ACT Math section. A few quick notes before we get into it, because I already gave my prologue last time we met. For this section, for these 30 questions in particular, since these are the toughest ones on the test, I'm not going to explain my algebra. If I, am subtracting 5 from both sides, I will mention that I'm doing that, but I won't show all my work just for the sake of speed. I want to make sure that I get to all the problems in a reasonable amount of time, which is the primary issue we had last time, is just running out of time. So this time I'm going to focus on the strategy for looking at a problem, identifying what's going on, and handling it, and not so much each individual step that I take along the way. So let's go ahead and get into it. It's going to take me a second just to sort this out, but once I have everything up and running, we'll be good to go. So let me make that transition. And we're starting off with number 31. All right. There we are. So, number 31, the first one that we're looking at. Already I see the word vector, which, you might think, okay, well, I don't really know much about vectors, but the good news is that they're really not going to test you on, vectors per se. Please note that they actually give you the definition of what a vector is in this problem. So one of the things that I noticed right off the bat is, they say that the vector I represents 1 mile per hour east. So we can assume, or I guess, I feel comfortable assuming, but this is also because I know how vectors work, that negative I would be 1 mile per hour west, for what it's worth. The vector j represents 1 mile per hour north. Okay, so I is the x-axis, j is the y-axis. Maria is jogging south at 12 miles per hour. Okay, so as I said, the same thing with negative I being west, south would be negative j. So if we're talking about 12 miles per hour, whoops, there we are. If we're talking about 12 miles per hour south, then that would be negative 12j. So the answer would be B, and we can move on. Not too bad. And then I'm going to do the same thing that I did last time, where I want to check my answers. So B, boom, there it is. All right, so moving on. 32. 4 identical glasses are shown below. One glass is empty, and the other 3 glasses are a quarter full, half full, and 4/5 full of water, respectively. If the water were redistributed equally among the 4 glasses, what fractional part of each glass would be filled? Okay, so this is kind of, or this is actually just an average problem. The big thing that you can't forget here is that there's an empty one. But yeah, this is just going to be an average problem. And while I think I can do this mentally, keep in mind that you're allowed to use your calculator on the test, so why not use your calculator? So 0.25 for the 1/4 full, 0.5 for the half full, and then I'm going to use, I guess that's 0.8. Oh, I know it's 0.8, but oh well, I already started with the 4/5. That gives us 1.55. And what I'm going to do is I'm going to divide that by 4 because we're redistributing it across 4 glasses. So divide by 4, that gives me 0.3875. Oh no, that's a decimal. Those are fractions. What do? Hit math, enter, 31/80. So that would be K. Let's go ahead and check that answer. And there it is. Moving right along today. 33. And let me get rid of my calculator work. Especially when we're dealing with areas. And the reason for that is that if you do, excuse me, sorry, I'm adjusting. If you do conversions for from inches to feet after finding square inches, then you actually have to do the conversion twice. If you don't believe me, just go ahead and draw a square, give it dimensions in inches, find the area, and then try to convert it back to feet. And you'll notice that if you were to do it in feet in the beginning, that it would be, you'd have to divide by 12 again to get to that number. So I'm not going to get into that, but for this one, right off the bat, what I'm thinking is, I think I'm going to convert the feet into inches. But what they're getting at here is what is the minimum number of carpet tiles that Aurelio must purchase to cover this area of his living room floor. So basically they're giving us, a big area like that, and then each of the tiles is like one little guy like that. And so we just need to find out how many of those work. Don't worry about, or for a lot of these problems, you don't have to worry about like overlap. Like in that previous example that I just wrote, or I just drew really quickly, you might think like, oh, well, what if it goes over like that? They typically don't worry too much about those in these problems. I mean, especially if it's like 33. If it's, the final 30 questions, but not the final 20 or final 10, I wouldn't worry too much about something like that. What you'll find, though, is 20 inches probably goes into 8 1/3 foot, 8 1/3 feet, like pretty evenly. And I'll actually test that really quickly because, that's something that's important to note for these problems. So that's 8 1/3 right there. I'm going to divide it. I'm going to multiply it by 12. And hey, let's just go ahead while we're at it. So that's 100 inches. I'm just going to go ahead while we're at it, and I'm going to say that's 100 inches. And 10 feet is going to be 120 inches. Cool. So 100 inches. And yeah, that's divisible by 20, as I said. And of course, 120 is divisible by 20. So, as I said, that's a really important thing to note. Okay, so we have a total area of 100 by 120. So I'm going to multiply 100 by 120. And then I'm going to divide that by 20 by 20. So divide by, in parentheses, 20 times 20, which I believe is 400, but I want to be super careful here. That gives me 30. basically the idea here, you know, if you didn't catch that, is area of the big area, the total area, divided by area of the single tile. And that will give you the number of tiles that we need. So 30 is our answer, which would be D. And so I'm going to go ahead and check that answer. Hey, on a roll. I do this for a living. I would be kind of bummed if I missed one of these, but hey, it happens. Let me take a quick sip of tea before we get going, before we move on. This is rooibos chai tea, and it is fantastic. If you've never had rooibos tea, please look for it. It is a South African bush, I think, and it's the weirdest flavor, but really, really special. All right, so right off the bat, I recognize this problem. I see the word circle. Just to be clear, when I say recognize, I actually haven't seen this test before. I see the word circle and I see the formulas here, and I know for a fact that what they're testing me on here is the circle formula, the equation of a circle in the xy plane. I'm going to take a moment just to turn up the brightness on my light. There we are. I'm noticing some weird shadows. All right. I'm a lot brighter now, aren't I? Okay. There we are. So, yeah, this is a really straightforward problem. I'm not even going to write out the equation because, as I said, these are the harder problems. You either know it or you don't. You can Google this if you want, but I see a center of 8, 5, and what that means to me is that it should be -8, -5. So it's either going to be F or G. A radius of 9, the radius is squared in the formula, so it's going to be F. And boom, let's go ahead and check that answer. Done. Awesome. They love those problems. I think there's like pretty consistently one of those on every test, and it's as simple as, you know, hey, if you know this formula, that's a free point. So it's worth knowing that formula. Okay, this is our first multi-part question. So I'm gonna grab 2 at a time here, like this. There we are, and then I'm gonna get rid of my calculator. I'll probably need it in a moment, but oh well. Okay. It is important to read these paragraphs up here. It's important. You're going to be looking at this question, or you're going to be looking at this material for 35, 36, 37, 38. It's 4 questions, so it's important to get it right. Many humans carry the gene YQ77. The YQ test determines with 100% accuracy whether a human carries YQ77. All right, it is important to write on your test, so 100% accuracy. If a YQ test result is positive, the human carries the YQ77 gene. It's 100% accurate, so yes, awesome. If a YQ test result is negative, the human does not carry. Okay, cool. Sam designed a less expensive test for YQ77, you go Sam, called the SAM77 test. Creative. It produces some incorrect results. Try your best, you know. To determine the accuracy of the SAM77 test, both tests were administered to 1,000 volunteers. Okay, so what I'm getting from here is they're designing a study where one of these is more expensive but 100% accurate, and the other test is cheaper but is less accurate. So they are testing it against the YQ test is the one that's 100% accurate. So they're testing it against this one to know, all right, how many false negatives am I getting? How many false positives am I getting? Awesome. It costs $2,500 to administer each YQ test. Okay, that is very expensive. And $50, yes, congrats Sam. Proud of you. $50 to administer each SAM77 test. What was the total cost to administer both tests to all the volunteers? Oh my gosh. Okay, so it's 1,000 volunteers. This is why it's helpful to read the paragraph. If you had started like trying to I don't know, it's not that hard of an extra step to add this up. That's 400, that's 600, it's 1,000, but it's nice to know, hey, it's 1,000 volunteers. I actually should have written more on that. 1,000 volunteers, and for each volunteer, I was right, I'm gonna have to bring out my calculator. For each volunteer, one moment. For each of the 1,000 volunteers, we are going to be spending $2,500, and then another 50. And I'm actually a little bit scared about how I'm going to do this order of operations. I I think what I'm going to do is I'm going to do 1,000 times 2,500. That's the one test, which is already, I mean, it's already, you can see, let me like make sure I'm counting my zeros there right, but, sorry, oh man, that's going to be really tough for me to do on my screen. 1 second. I'm really struggling to see the number of zeros. All right, 1, 2, 3. So 2,500,000. Many of the answers are already below that. So I think it has to be E. Let me just make sure I'm reading it because that feels way too easy. All we'd be doing next is adding 1,000 times 50, which is going to be 50,000. I already know it. So yeah, it looks like E is right. Let me just make sure I'm not missing anything. 2,500 to administer each YQ test, and 50 was the total cost to administer both tests to all the volunteers. So all the volunteers are getting both. So 1,000 people get the 2,500. Wow, that's an expensive test. Okay, so yeah, I'm gonna go with E here. I'm not gonna lie, I'm a little bit concerned that it's too easy. But hey, you got to be confident and know you'll believe in yourself on test day. So there we are. It's important to believe in yourself. All right, 36. What % of the volunteers actually carry YQ 77? All right, so remember, this is that 100% accuracy thing. And I got rid of my notes a moment ago, but the 100% accuracy, so if they have a positive YQ test, they actually carry YQ 77. So that is going to be both of those. Positive YQ test means that it's this whole area that's positive, that whole area, regardless if it's a positive, negative, SAM 77. So 590 plus 25. Oh man, I have to do some math. Gosh, on the math section, I actually have to do some math. 590 plus 25 divided by 1,000, so that's going to be 61.5%. So J. I almost did just an unnecessary step, but oh well. All right, so J, let's check it. It's J. 37. If you were here for the previous stream, you might remember that I was going a little bit slower. First off, I wanted to make sure I was going into more detail on the easier problems because, you know, if you want to see those problems, you know, you might benefit from seeing them a little bit slower. The other thing I was doing at the time was I was classifying each of the problems. I'm not going to do that tonight. I decided that it took way too long, and as I already said, the main constraint last time was time. I want to get through this test, and I can always go back later and classify these problems. So I will be working on this test with some students this week. So I will have plenty of time to look at that later. 37. For how many volunteers did the SAM 77 test give an incorrect result? Okay, so we're looking at these right here. We're looking at the positive YQ test, but negative right there. So that one right there, 25, and then negative YQ test, but positive. So basically just the ones that are, remember, the YQ is the ones that's 100% correct. So the ones that are, you know, not on the YQ 77, not what they are in the SAM 77. The ones that mismatch. So 35, which would be C. So let's check that real quick. Boom. And now we're on to 38. Flying through it. This is much faster than last time. One of the volunteers whose SAM 77 test result was positive will be chosen at random. Okay. So who's SAM 77? So that is 600 people who had a positive SAM 77. Break problems down. Don't wait till the end to start figuring out, you know, the numbers. Already I want to know how many people that is. One of the volunteers of the 600 is the way I'm reading that now. To the nearest 0.001, so that's telling you can round. You have to get permission to round on this test. What is the probability the chosen volunteer does not possess YQ 77? So does not possess is the same thing here as a negative YQ test. So that would be 10. So the probability would be 10 over 600 because it's the negative over the total. and the total is 600. So not 10 over 590. Though I would bet that one of the answers is 10 over 590. I'm not going to test that because that's not the purpose of this broadcast. So what is the probability? So I'm getting 0.016. So 0.017 is F. All right, let's check it. I'm actually scared I'm going a little bit too fast. But, oh well. Oh, cool. So matrices problems show up not that frequently. If you will give me a moment just to take another sip of tea. And I would just like to say matrices problems don't show up that frequently. And that's partially true. They show up maybe once a test. And I said that about the circle problems too. But on these problems, our matrix problems, they show up in a lot of different ways. So, you know, knowing how to multiply them, which actually I'm rusty on, so they might get me with this one. What I believe is you do -1 times -2, which would give you 2, plus, and then let me color code this, 0, I missed it, 0 times -1, so plus 0. So I think it would just be 2, which is D. But multiplying matrices is something that if you haven't done it before, sorry, letter D. Cool. If you haven't done it before, it's worth watching a YouTube video on it. You know, if enough people ask, I'll make a YouTube video on it happily. There I'm always like, you know, I'm always asking my students, you know, what they think would be the most helpful thing for me to make a video on. I record a lot of our lessons and like share the stuff that I think is the most important with them. You know, that's one of the things that I like to do for my students. But you know, something like this that's not that common, I don't really put a lot of priority into unless I have a lot of students who are saying, no, please, 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 I really want to know how to do this. All right, so 40. Regardless of how the graph is oriented, actually, hey, give me one moment. I want to just check chat really quickly because I haven't been. And last time I actually ignored some messages and I don't want to do that. Okay, so there we are. Regardless of how the graph is oriented in the standard XY coordinate plane, no graph in one of the following categories has a vertical line of symmetry. Okay, so vertical line of symmetry means you can cut it in half down the center. So right off the bat, you know, I know that a line, you know, they said regardless of how the graph is oriented, so that means like, they're not saying like a square oriented like this. Actually, that one kind of does. A square, here, give me a moment. They're not saying like this. Give me one moment to do this right. They're not saying a square like that. They're saying regardless of how. So if you give me a square like that, they're saying that I can actually make it like that. And yes, that does have vertical symmetry. So line, square, definitely off the table. Pentagon, off the table. You can go straight down the center of a pentagon. Parallelogram. A parallelogram is tricky, but I do believe it would work because the way that a parallelogram works, you might think, oh, well, you know, obviously, you know, that's not perfectly symmetrical like that, but it's sort of the same thing I was saying with a square. I can rotate that. And I do believe, like, this one obviously doesn't work, but I do think that, like, a diamond would classify. I would have to check myself on that one. But I think that would work. So, yeah, no, I think it would work. So, oh, and a square is technically a parallelogram. Am I right about that? Yeah, no, I mean, what I see, though, is, you know, even if I'm, like, doubting myself here, scalene triangle has to be it, because scalene has 3 different length sides. That's just not going to have any vertical symmetry. It just won't. So that one would be K. There we are. All right, moving on to 41. All right, so the final 20, these are going to be the most difficult problems that we've done thus far, in theory. Sometimes you get some easy ones, or some like tricky ones sprinkled in there that really it's not that they're that hard. It's just testing a concept that not a lot of students know, and if you know, it's easy. So, 41. The equation, blah, has two solutions. What is the greater of the two solutions? Great. If you see x squared, you should immediately think, I need to factor this. And that's what we're going to do here. So I'm going to do two steps. I'm going to do, let me use a different color here. 24x squared plus 2x minus 15 equals 0. Oh, I thought I was going to divide by 2, but no, I'm not. All right, so I don't want to factor this. I'm going to use the quadratic equation, the quadratic formula, because I think that would be the easier thing here. Actually, I'm going to do something even cooler. I hope this blows your mind. I really shouldn't do this. Yes, I'm the founder of Lee Tutoring, and I can do what I want, but I'm going to get flack from somebody for giving away this super cool calculator trick. So, I don't care. I think it's a really cool trick, and I want to share it. So 24x squared plus 2x minus 15. Now you might be thinking, oh, Edward's just going to graph it and look where it hits the x-axis. Easy. Yeah, Edward could do that, and that's not a bad idea. That's not bad. However, what I could do is I could use the table, and I can type in 0.75. Okay, that's one of the solutions because it equals 0. So that's one of them. Let's see if 4 over 3 also works. No, it doesn't. Let's see if 5 over 6 works. No, it doesn't. Let's see if 7 over 6 works. 20. And then 11 over 15. Which I don't even think is bigger than 3/4. So there it is. Our answer is 3/4. If you're wondering how I did that, I used the table setup. I set independent to ask, not auto, and it's very helpful. Honestly, I could have stopped at 3/4 because I knew that the other answer was negative from looking at the graph. Don't forget that you have a graphing calculator. Use it. It is incredibly helpful. Just make sure you know what you're doing and when. Again, that's one of the other videos I really want to make is a bunch of calculator hacks that I have used over time. So 41, the answer would be A. There we are. Awesome. 42. Which of the following expressions is equal to blank? Okay, so here's the thing. I don't know trigonometry identities off the top of my head. I don't know the trigonometry identities that this thing is. I bet it's something like, oh, it's just sine 30 plus sine plus cosine 30 or cosine 60. Or maybe it's like sine of 90 or cosine of like 90. I bet it's one of those identities where it's just you can, if it adds up to 90, you can break it up into 30 and 60, and this thing is true. Yeah, something like F, G, H, or J. I don't know which one is which. So what I'm going to do is I'm going to use my calculator. And this is just because this year I have a bunch of Algebra 2 students, a bunch of Calculus students, but no Trig students, which is weird. Last year I had 2 or 3. Anyway, I'm just going to find out really quickly what is, and I'm going to make sure that I'm in degrees. Make sure I'm in degrees. So I'm going to find out what is sine of 60 times cosine of 30. This is going to take a while to type out, but this is the best way that I have of doing this. Okay, so that's 0.75. And then cosine of 60, I used one too many parentheses last time. I want to do this just the easy way. Times sine of 30. Adds up to 1. I told you, it's going to be something of 90. Okay, so if it adds up to 1, so 0.75 plus 0.25, that adds up to 1, that means it's either going to be sine of 90 or cosine of 0. 60 minus 30, yeah, so it's going to be sine of 90, which would be J. And look, I'll just prove it really quickly. Sine of 90 gives me 1. Those things are equivalent because they both equal 1. That's what equivalent means. So let's go ahead and J it is. Awesome. You don't need to memorize all these fancy identities. You just don't. I think that it's important to prepare for these tests the smart way. And, you know, some people might think that it's lazy not to memorize those identities, but I actually think it's a mistake to overcommit yourself to, you know, memorizing stuff that you're not going to end up using. I just think that's a mistake. 43, what is the area in square units of a circle that has a circumference 12 pi units long? Okay, I think this is a good example of one of the problems that's at the end of the test that's really not that bad. Circumference is equal to 2 pi r. It's also pi d, diameter, but since I want to get it into the area, I want the radius. So I'm going to set 12 pi equal to 2 pi r. Honestly, and they made this a little bit too easy by making it 12 pi. They didn't even do anything, like, they didn't even do any, like, really annoying numbers. So we have 12 equals 2r, 6 equals r. I hope I'm not doing this too fast. Then we know that the area equals pi r squared, so that's going to be 36 pi. All right, so that's D, which means that, hey, there it is. As I said, it's not that hard. It's supposed to be one of the hardest ones. One of the things that I tell my students is there's a dance move from the 90s that's the equivalent of, like, flossing nowadays. It's not really a dance move, but people, I guess some people do it, but it's a meme. They had memes in the 90s. It's crazy. It's the I could be wrong. I'm pretty sure it's the 90s, but it's like the shopping cart. You, like, grab stuff off the aisle, put it in your cart. I like to tell my students that when you're, depending on where you're scoring, if you're shooting for a 36, this is still helpful to some extent, but depending on where you're scoring, it's important to be able to, like, walk down the aisle and say 41, no, 42, no, 43, yes, 44, no, 45, no, 46, yes. 43 is one of those ones where even my students who are, you know, not shooting, you know, are scoring, like, in the 20s and shooting for a score in the 20s, I think that, like, they should still look to the end of the test to try and get this one. Some of the other ones might be a waste of time. You know, it's important to focus on that, on the stuff that matters more, or the higher value. It's important to set priority is what I'm trying to say. Okay. Gonna take another sip of tea. We are flying through this. Oh my gosh. Halfway through, and already, like, 30 minutes less than the previous one. Well, projected 30 minutes less. I did something right. I have had earbuds in this entire time. I'm not even using them. All right, so a barrel contains 25 liters of a solvent mixture and is 40% solvent and 60% water. Ooh, I don't like this one right off the bat. I'm not gonna lie, I really do not like this one. Okay. I'm gonna take my time with it. It's important to know what you know and what you don't know. It's one of my favorite of the Delphic maxims. Know thyself. Alright, so a barrel contains 25 liters of a solvent mixture that is 40% solvent and 60% water. Lee will add pure solvent to the barrel without removing any of the mixture currently in the barrel, so that the new mixture will contain 50% solvent and 50% water. How many liters of pure solvent should Lee add to create this new mixture? So I think that what this is going to come down to is me ignoring the 60% water. Bear with me on this. My thought process is I need the amount of solvent to be equal across the board. So I'm basically going to take the 40% solvent and multiply it by 25. So 0.4 times 25. And I'm going to add that times 0.5, which is the percent of the solvent that I'm going to add. Oh no, sorry. My bad. We're adding pure solvent. So it's 100%, so just 1. Which, you know, I'll just put it in parentheses then. Pure solvent in what amount? And that's going to equal, that total amount is going to equal 0.5, that's the 50% solvent, of, and I'm running out of room here, so give me a second, this is just my bad planning. That's going to equal 0.5 of 25 plus x. And again, that x is, I put a question mark here. That's just me being silly, but let me just read over this one more time. So what I'm tracking is just the amount of solvent. If we have 40% of 25 liters, that's a certain amount of solvent. If we add a pure solvent, so that's going to be that's going to give us a number of liters. This is also going to give us a number of liters. If we add those together, they should equal whatever this number is. And that number right there is going to be, this right here is the total amount of, stuff that I've added, the original amount that I started with plus the amount that I added. But since only 50% of that is solvent, I'm putting that 0.5 in front. So, I need to find out what 0.4 of 25 is. I'm going to need to break out my calculator for this. And this might be a little bit visually disorienting, so I'm going to be careful here. I'm going to do the math. I'm going to use the calculator right here with the numbers on top of it. But 0.4 times 25 is 10. And then, so yeah, let me just write that as 10 really quickly. Plus x equals, and then 0.5 of 25 is 12.5, which is an ugly number, but 12.5 plus 0.5x. Okay, I'm going to get rid of the calculator really quickly. And I can solve this. Subtract 0.5x from both sides, that gives me 0.5x over here. Subtract 10 from both sides, that gives me 2.5 over here. So my answer will be 2.5 divided by 0.5. I'm hoping this goes well. I'm a little bit about it. Alright, so let's see. 2.5 divided by 0.5 is 5. So that would be G. I'm not going to check it. I'm going to check the answer. Oh, I'm not going to check my work. I'm just going to check the answer. If we're right, awesome, let's move on. If we're not, let's find out why. So I said G, right? There it is. Yeah, so I've seen problems like this before on the SAT, actually. But the same format. Same approach. Let's move on. I don't want to over-explain it. All right, 45. Oh, I love these problems. They're setting up a conjugate for you. Honestly, I'm surprised that they don't make you do the work of coming up with a conjugate as the solution yourself. So, what we're doing here, oh, actually, no, sorry, this isn't a conjugate. Conjugate, it is, but it isn't. I thought that was a multiplication sign. What I'm going to do is I'm going to multiply this guy times x minus y over x minus y, and I'm going to multiply this guy over here times x plus y over x plus y. So that's what I mean by conjugate. X plus y is the conjugate of x minus y, and what we want to do is we want to get a common denominator here, so that's why I'm doing that. So, on the left-hand side, that's going to be x times x, so x squared, that's this x right here, times the, and I'm in the numerator, x times x, x squared, minus xy. This is all going to be one term in a moment, so I'm just going to do it all in one fell swoop. So plus x times y, this x times this y, and y times y. So plus xy minus, plus y squared. That's par for the course. That's exactly the type of thing where they want you to see that cancel out. And that's funny because that's what's happening on the underside, and that's the importance of conjugates. Conjugates, when multiplied together, give you a difference of squares. I don't even need to do the math. I just know that x plus y times x minus y is x squared minus y squared. I just know that that's what it is. So x squared minus y squared, which means that it's going to be x squared plus y squared over x squared minus y squared. And that is going to be E. It's important to slow down when selecting answer choices. There are answer choice B there could easily, for all of my good work, all my awesome math, could totally throw me off, and then I get a wrong answer for just being a little bit too rushed, and that's a problem. It's important to slow down when looking at answer choices. All right, 46. Mary, James, and Carlos sold 1/4 page advertisements for the school yearbook. Mary sold twice as many as Carlos did, and James sold 3 times as many as Mary did. Congrats, James. what fraction of these advertisements did Carlos sell? I'm going to go ahead and I'm going to create a variable for each of these as necessary. So we're starting off with, 1/4, obviously not a relevant number. Just feel like pointing that out. Mary sold twice as many as Carlos, so M equals 2 times C. James sold 3 times as many as Mary did. Okay, so J equals 3 times M. What I'm going to do is something kind of cheesy, but it works. I'm just going to come up with a number for Carlos. It doesn't matter what the number is, because the fraction, the proportion, all that's going to stay the same. It's proportional. So if I just say, all right, C equals, let's make it a nice number, 2. Actually, I'm going to be a little bit annoying here. I don't like to use 2. I'm going to use 3. So if C equals 3, that means that M equals 6. Gesundheit. My dog sneezed. She needs to be blessed. So C equals 3, M equals 6, and J equals 18. Now I have actual numbers to work with. What I'm going to do is they want to know what fraction of these advertisements did Carlos sell. Well, that would be 3, his number, over 3 plus 6, which is 9, plus 18, 27. So that's 1/9. I hope. Am I doing something silly at the end there? Genuinely, I don't trust myself at this point. That's correct, F. Again, you can do that a bunch of different smart ways, but plugging in numbers works, so why not? We're moving on. Oh, okay. I immediately recognize this problem as a combinations problem, because I see, note, the positions of the unselected plants do not matter. Earlier I said that I haven't seen a lot of these problems. I think I have seen this one, because one of the things I do is I put together, when working with students, I look over a bunch of different tests, all of the, there are a bunch of sample tests out there, and if a student has purchased a book, I'll use some of those as well, but I put together a bunch of problems of the same problem type, and I think I've seen this one before with a student, when talking about combinations and permutations. So this is similar, for instance, to the problems where it's hey, you can choose a salad, a sandwich, and a drink from this restaurant. They have this many options for each of them. How many different combinations of things can you get? You want a water out of 5 options, 5 other options maybe, but you choose a water, you choose a Caesar salad, and you choose a Reuben, right? So that's one combination of however many that you could do, as opposed to water, Caesar salad, and ham sandwich, for instance. Okay, so this is a similar idea. Give me one moment, please. Okay, similar idea. I do the same thing for all these problems, regardless of how easy they are. I like to draw out little spots, and I think it's going to make a lot more sense on this one. It says, in a window display at a flower shop, there are 3 spots for 1 plant each. So 3 spots. To fill these 3 spots, Emily has 6 plants to select from, each of a different type. Selecting from the 6 plants, Emily can make how many possible display arrangements with 1 plant in each spot? So how many different display arrangements can we make? Okay, well, what you have to think of is how many, you go from left to right, you say, how many plants can I put right here? Well, I have 6 plants, so I can put 6. How many can I put here? Well, I've already used one of them, so it's actually going to be 5. And how many can I use right here? 4. Now, those of you who have done your homework in school and are great students, or maybe those of you who know better than me, will say, oh, well, Edward, there's a formula for this. It's, I think it's something like n factorial over n minus r factorial, something like that. Cool. Proud of you. I don't care, because this gets the job done, and it applies to other problem types that are similar to this one, and I don't have to memorize the formula, even though I have. But this works sufficiently well. So it's going to be 30 times 4, which is 120, and that's D. I feel very confident in this one. There we are. All right, moving on. For those of you that know that formula, though, proud of you. Keep it up. It's important to pay attention in school. I'm a big fan of school. I wasn't so much in high school, but I am now. Okay. Let's see. 48. It's kind of awkward there. Sorry, 1 second. Let me just get a little bit better. There we are. So, in terms of A and B, what is the area in square coordinate units of MPQ? Alright, so I see MPQ right here. That white isn't really helpful. There we are. So MPQ. Okay, so what is the area in square coordinate units of that? And they say in terms of A and B. So what do they mean by that? Point M is 2A. Oh, in terms of A and B, because this whole thing. Remember earlier I said when reading one of these problems that has multiple problems attached to it, read the whole paragraph? I didn't do that. So the quadratic function of f and that triangle are graphed in the standard xy coordinate plane below. Points M and P are on F. Points Q, or point Q is not on F. Cool. So it's also important to check your x and y axes and see if there's anything weird like this going on. Sometimes like they'll be going at different rates. One of them will be like the x-axis will be going up by 0.25 and the y will be going up by 1. It's important to keep track of that stuff. So what are the, okay, sweet. So what I see here then is the area of a triangle is 1/2 base times height. So we have 1/2 base times height. The base is going to be from M to P, which is from 2A to 6A, so that's 4A. So, sounds like the word 4A. We're taking a 4A into math tonight. 4A. The height is going to be from 5B down to 0, so 5B. So that's 1/2 times 20AB, which is going to be 10AB. Not that hard of a problem, but they're trying to mess with you with that A and B thing. And I don't know, maybe I made a silly mistake along the way and I'm oversimplifying it, but that would be G. Honestly, I'm kind of hoping I miss one at some point, so I gotta like go back and show you how I would problem solve, how I'd troubleshoot it. But alas, I've actually genuinely been wishing to miss one of these. I know that sounds weird. Alright, so point M will remain fixed. Okay? What are all the other points doing though? 1 second. Okay, there we are, that's way better. Point M will remain fixed and point Q will move to the right along the x-axis. Okay, so we're going to be moving Q to the right. As Q continues to move to the right, which of the following statements describes what will happen to the slope of MQ? The slope of MQ right now is negative something. It's just negative. Let's just say negative x. As this moves, it's going to, let's just like choose a point all the way over here. So this is a more steep line. That's really ugly, sorry. But that's a more steep line, so that's going to be like a negative big number. This is going to be like a negative like 1 over 2x or something. So it's becoming less negative. Let me make sure I'm right about that. Yeah, it's becoming less negative. Eventually, you know, if we were to continue the process and move it up this way, it would eventually become positive. So it's becoming less negative. So it will decrease and eventually be negative. Well, it's always negative, so A is wrong. This is going to be a good process elimination problem. It will decrease but never be negative. False. It will stay the same. That's definitely false. It will increase but never be positive. It is increasing. It's becoming less negative, as I said, which is the same thing as increasing. I'm going to go with D. It's not E. So yeah, that is a good process of elimination problem. We haven't seen any tonight where I had to go like one by one, except for that one where I plugged in all the values. That one counts too. But process of elimination. That's going to be D. Boom, on a roll here. All right, 50. One of the following values is equal to f of 5a. Oh, cool. So they're just testing you on functions here, making sure that you know how to read a function, function notation. I'll just tackle this one real quick. F of 5a, what that means is you look for 5a, which is this one right here, and then f, remember, is the quadratic function. Here, let me get that in there, quadratic function. So f of 5a is all the way up here. So that would be 8b, which is k. That's it. Boom. All right, we're on the final 10. So I'm going to take a quick break here. I just want to stand up and like move around a little bit. But yeah, we're flying through it. So please bear with me. I'll be back in probably a minute or two. Thanks again for tuning in, though. Okay, and I'm back. So, doesn't look like we lost any viewers. Yay. Look at that. I appreciate y'all for sticking around. So, final 10. We got 35 minutes. That's the score to beat. Here we are with number 51. 12 jurors, rural jurors. They are jurors from a rural area. 12 rural jurors are needed for an upcoming trial. The diagram below illustrates a part of the process of jury selection. The 12 jurors will be selected from a jury pool of about 60 people. The court records show a trend that only 40% of the people who are summoned for jury duty actually appear, and that of the people who appear, a third are excused. Okay, this is a lot of information. I'm going to push through to the end. I'm going to look at what they're asking me, and then I'm going to try and go back through this information again. It's important to like underline, and I'll be honest with you, I'm taking some shortcuts. That's my privilege as a tutor, but I would highly recommend keeping track of all these figures that they're giving you. I would actually recommend starting with the final sentence first. On word problems, that's typically a good thing to do, is just, hey, what am I looking for? If the same trend continues, so, okay, let's imagine we hadn't read it. There's some trend, and if it continues, how many people should be summoned to have as close as possible to 60 people in the jury pool? What I want to point out is that we want this number to be 60. So we're going to be going backwards. And I think that that's an important thing to point out right off the bat, is we need to find out, okay, from the jury pool that they give us, how many, that's X percent or whatever of those who appear, and then those who appear are a certain percent of those who are summoned. So we're actually going to be working backwards. So what's the relationship then between appeared, excused, and the actual jury pool? Now I know what I'm looking for when I go up on the word problem. The court records show that a trend that only 40% actually appear. Okay, so that's did not appear. And that of the people who appear, okay, so that's those who appeared, 1/3 are excused. So if 1/3 are excused, 1/3, that means that this jury pool right here is 2/3 of those who appeared. So that means that those who appeared, 2/3 of those who appeared is 60, the actual jury pool. Another way of writing this is 2/3 A is J, and then we plug in 60 for the J. So that means A equals 60 times 3/2. Just going to do some mental math here. 60 divided by 2, 30 times 3, 90. Just keep that in mind that, you should really use your calculator for like any basic arithmetic. I think it's a really good thing to do to be safe. But practicing mental arithmetic is also helpful. Okay, so we have A equals 90. Now let's go back and look at the other rule. I'll do this in red. So we know that appeared is 90. So what's the relationship between the rural jurors who appeared and the rural jurors who were summoned? So the court records show a trend that only 40% of the people who are summoned for jury duty actually appear. So 40% of those who are summoned. So again, new equation, 0.4 of those who summoned equals, again, 40% actually appear, so that's 90. S equals 90 divided by 0.4, which I want to break out my calculator for, but 0.4 is 2/5. So I can multiply that by 5/2. I don't want to do that. I'm going to do 90 divided by 0.4. Know your limits. As I said earlier, my favorite of the Delphic maxims, that is maxims inscribed on the Temple of Apollo at Delphi, my favorite of those maxims is know thyself. I know I can't do that. Well, I can. It's easier to do it this way. So 225. So my answer is going to be D, 225. And let me make sure that that's what I'm looking for. That's the number S, that's letter S meaning summoned. And they said if this same trend continues, how many people should be summoned to have as close as possible to 60 people? If I wanted to check this, I would do, okay, what's 40% of 225? And then what's 2/3 of that? But you know what? I trust it. 225, that was D. All right, let's go. 52. Rural Juror is a reference to a TV show, by the way. I'm not just being weird. If you know it, you know it. If you know, you know. What is the 275th digit after the decimal point in the repeating decimal 0.6295? I like this problem a lot. Okay. This is one of those problems that I think is really cool. They do the same thing all the time with, like, what's I to the 275? And the thing about I is that, like, I to the first, second, third, fourth repeat. So I to the fifth is the same thing as I to the first. I to the sixth, same thing as I to the second. This is what they're doing in this problem. Immediately I recognize it. Immediately I know, okay, 275th digit. Essentially what I'm getting from this is 1, 2, 3, 4. There's 4 digits. If I take 275 and I divide it by 4, and my remainder is 0.75, that means that the digit is 3, digit is 9, because that's the third of the 4 digits. 3 over 4, 0.75. I might not be doing the best job of explaining that one, but basically, if I take 275, it's the same thing as the I to the second, third, fourth, and fifth thing, where the 5th digit would be another 6. That's the 5th digit. And if I take 5 divided by 4, that's 1.25. The 0.25 is 1/4, and that 1/4 means, oh, hey, look, I'm looking for the first digit. So what I'm going to do is I'm just going to take 275. I already think it's going to be, it's either going to be 6 or 9, because it's either going to be 1 over 4 or 3 over 4. So 275 divided by 4, 0.75. So it's going to be the third digit, which is 9, so K. There it is. I love these problems. I think that's such a clever problem. And if you know it, it's just super easy. If you're not really sure what I did there still, please reach out. I'd love to explain that problem a little bit better. But as I said, we're going for speed here. All right. Given that f of x equals x squared minus 4, okay, so they're giving us an f of x and a g of x. They're doing function composition here. They say, what are all the values of x for which f of g of x equals 0? Okay, so I'm tempted to use my calculator here. F of g of x means that wherever there's an x in f, we're going to plug in x plus 3. So it's really not even that bad of an equation to composite. It's going to be x plus 3, and then what I'm going to do is I'm going to color code this a little differently. X plus 3 squared minus 4 is what f of g of x equals. Let me just get my color coding there right. Boom. I'm sorry, that's really cramped. Not easy to see. So f of g of x equals g of x in the place of the x squared minus 4. I can just plug that in the calculator. I'm going to do it. It's an easy problem for me to solve out. Set it equal to 0 and factor. But again, this is that really cool calculator trick that I love showing off. X plus 3 squared minus 4. And then I'm just going to go over here and I'm going to plug in each of those answers. So -5, -1, -3. Oh, both those are 0. That's A. It has to be A. It's that easy. I'm hoping that I get it wrong, so I get, nope, that's it. It's that easy. Those -5 and -1 gave me 0, and they were asking for it to equal 0. So I plug in that equation, I plug in the numbers that give me 0. That easy. I love that trick. Okay, so 54. Ooh, this one looks fun. I'm sorry. I always joke with my students, I don't know. It's never a good thing if a math tutor or teacher says, oh, this one's fun. It's not actually fun. Okay, so given that p is a positive number and n is a negative number, and, okay, so this is the big thing. That means that the magnitude of p, the actual value, regardless of, positive, obviously a positive number is going to be bigger, but the magnitude, if we make both of them positive, the positive number is greater. So which has the greatest value? If we want the greatest value, we want to be dividing by n, because it's a smaller number. I'm a little bit concerned about the difference between h and k. Because here's the thing. If p is 5 and n is -4, 5 is greater than 4, and that difference is 1. Okay, well that means h is an awesome answer because we're dividing by 1. Cool. Oh, wait, no, it's not 5 minus 4, that'd be 5 minus -4. So that'd actually be a bigger number. So never mind, I take it back. Be mindful of where the absolute value actually is. That's actually going to be the biggest one. We want the smallest number on the bottom. I'm getting rid of p from all of those. I feel very comfortable with these problems that it's sort of a piecemeal thing. You can look at the denominator and then look for the most favorable denominator, and then look at the numerator and look at the most favorable numerator. P plus n, we want it to be the biggest, so p plus n is wrong because keep in mind n is still negative. We haven't done the absolute value yet. So we want it to be p minus n because that's 5 minus -4, 5 plus 4, 9 divided by n. So I'm going with G here. This one is tricky. That's kind of a theory problem. I was really hoping that'd be the first one I missed, but man, darn. Anyway, yeah, that's a theory problem, and I want you to. It's sort of like in the science section where sometimes they're like, what confluence of variables? We want we have this variable A, variable B. What gives us the greatest value of variable C? And they're never gonna have you do an okay value of A and a really good value of B with a really good value of A and an okay value of B. They're never gonna make you do that mental calculus and try and balance it out. It's always gonna be the best A and the best B. If that makes sense, awesome. If it doesn't, ask me what I mean by that and I'll clarify later. Okay, here's an I problem, kind of like what we were talking about earlier. I know for a fact, I think I'm going to do the thing I was talking about earlier. So I know that or plus I to the third equals 0. That's because I equals the square root of -1, and I to the third is negative square root of -1. And I honestly, I only know that because for that problem I talked to you all about earlier, like I to the 5,000 or whatever, I always write out I to the 1, I to the 2, I to the 3, I to the 4 for my students. So I know that those equal 0, which means I can get rid of this one and this one, and it's just I squared on top divided by, now let's look at the denominator, I to the third and I to the fifth. As I said, I to the fifth is the same thing as I to the first, so those also cancel out. It's I to the second over I to the fourth, and those are the same thing, just negative, so that's just going to be -1. I squared is actually literally -1, so that's, let me color code this. I to the fourth is going to be +1, and I to the second is -1, so that's just -1. Boom, B. We have 5 problems left. Wow. Actually, we are kind of catching up. I'm going to beat my previous stream's time, but pretty proud of how quickly I was able to do this. Okay, so I'm going to try and get this all on one page, like kind of reasonably. Yeah, I feel kind of comfortable doing it like this. This is going to be a little bit confusing to look at, but let's just do our best to make sense of it. In one of the following graphs, in the standard xy coordinate plane, the solution set to the system of inequalities below is shown shaded. Which one? Okay, which of these graphs is the correct graph of that system of inequalities? And by that I mean that system of inequalities. Okay, so let's make sense of it. X plus 2y is less than or equal to x, or 6. I'm immediately going to want to put that into y equals mx plus b. I want to point out that f and j have two different slopes. G and k, actually, yeah, j's the only one with a positive slope there, but I'm sure I said this last stream. If I see a linear equation, I want it in y equals mx plus b form, no matter what. So 2y is less than or equal to -x plus 6. That means that y is less than or equal to -1/2 x plus 3. So j is wrong because that's a positive slope and our slope is negative. Okay, now you could graph this yourself, but yeah, you could graph this yourself, and I'd actually recommend it. The tricky thing is with the circle graph. With a circle graph, you have to take the square root and do y equals positive square root and y equals negative square root. But what I'm going to do is I'm going to try and do a process of elimination here. They're saying y is less than or equal to 6. So that means that it has to be less than that line. So f and k are both doing it right. H is doing it wrong. Okay. With that said, I'm actually going to get rid of that one now. H is doing it wrong. We can get rid of H. So now we're looking at, oh, and then G has a dotted line. That dotted line right there is not what this means. Less than or equal to means that the equal to is allowed. Unless there might be something to the fact that it's the solution to the system of inequalities and we're only doing the inside of the circle. This one's actually a little bit trickier than I thought. I don't want to underestimate it. So the big thing is, are we filling in the inside of the circle or the outside of the circle? And we're really looking at F, G, and K. One of the things that I'd like to point out that I could actually do right off the bat to get rid of F or see if F's the right answer, we know that the y-intercept right here is 0, 3. That's this right here. So I could just plug in 0, 3 into the circle equation, and if it checks out, then we're good. I want to rewrite the circle equation as 3x squared plus 3y squared is greater than 12. Ooh, immediately greater than 12 means that it's doing the outside. So it's not going to be g. It's not going to be g. And then if I plug in 0, 3, what do I get? I get 0 plus 3 times 9, which is indeed greater than 12. So that means it would be outside of the radius. So f is wrong too, because what this means right here is that the actual circle, or the point that we plugged in, is going to be outside of the radius, which is the square root of 12. Actually, it's not the square root of 12. This is a weird formula. This is a weird form of the circle, but nonetheless, it's going to be k. And this might be the first one I get wrong. I think this is the first one that's messed me up. Gosh darn it. It's going to be k. Yeah, so the thing that they're doing here, I'm not going to get too deep into this, but the thing that makes this one so tricky is that they are not giving you the circle equation in the way that you're used to seeing it. If you wanted to actually find out, like, what... Oh, actually, no. I thought you had to do a... I thought you would have to do a... Oh, I'm totally blanking on what it's called. Complete the square. I thought you'd have to complete the square, but you don't. It would just be x squared plus y squared is greater than 4. That's it. And so that's why you know, it's right around. That's one of the things I could have checked for. It should be right around the origin, and it has a radius of 2. So yes, it should be less than the y-intercept at 3. Oh, I could have done that much faster. I totally let that one get to my head. Okay, so 57. Oh, I didn't check. Did I check that one? Yeah, I did. Let a, b, c, and d be real numbers. Given that ac equals 1, b plus c over d is undefined. And, oh, okay, they're giving me a lot of information. Which of the following must be true? All right, a equals 0 or c equals 0. When I see something is undefined, that means that d is 0, right off the bat. If d is 0, okay, I see how I'm connecting this. We're dividing by 0, that's why this is undefined, which means that a, b, c equals 0. So, if a times c equals 1, that means neither of those numbers are 0, which means it has to be b. B is 0. D is the answer. I am certain of it. There we are. Tricky problem, kind of like a puzzle. Oh, I just did something goofy. There we are. 58. A cosine function is shown in the standard xy coordinate plane below. Alright, so it looks like it's... oh, I need to actually read the question. Which of the following equations represents this function? I combined those two sentences, but which of the following equations represents the function? So it either has an amplitude of 2 or an amplitude of 3. Looks like it's 3. So f and g are both wrong. Boom. Why does it do that? There we are. Okay. Now, this is the part that actually might catch me. The inside here is what determines the period. If you do 2 pi divided by that number, I think... actually, no, this is stupid. Excuse me. This is silly. I could graph this. I do feel really comfortable knowing or arguing that the period is equal to 2 pi divided by, I think the variable that we use is b, but I could be wrong about that. And that's for cosine and sine. For tangent, it's pi divided by b. But for this one, our period is, if this is pi over 2, that means this right here is pi. So our period is pi, which means pi equals 2 pi over b. So b equals 2 pi over pi. B equals 2. I think it would be k. I'm going to go with that. If I'm wrong, I'm just going to graph it. It's k. Yeah. You can just graph these. You can just graph those 3 and then say, hey, do they look like that one? And check each of the major points. Check, okay, you know, you compare the periods. All right, 59. We're almost done. Woo. Okay, the figure below shows a flying kite. At a certain moment, the kite string forms an angle of elevation. Oh, 1 second. Okay, 75 degrees. That's what they're telling me. Cool. At the same moment, wow, it's 240 feet. Wow, it's the same thing in the drawing. 45 degrees. Wow, it's also right there. Okay, so this is why I say, when reading word problems, always look at the last sentence. They're just describing the drawing. What is the length in feet of the string? Okay. I think I'm going to use the law of sines here. If we want the length of the string, remember, you cannot use Pythagorean, or you can't use Pythagorean theorem here, and you can't use SOHCAHTOA here. Those are only for right triangles. So I'm going to use the law of sines here, which states, give me a moment, the law of sines is basically sine of an angle divided by the side opposite that angle equals sine of another angle divided by the side opposite that angle. Now, I should also do equals sine c over c, but I'm not going to write that out because I have what I need here. We have this guy right here. I think we could also do, no, we couldn't, never mind. We can't do law of cosines here. You're going to have to find this one right here by just using like triangles out to 180. So 75 plus 45 is 120, so that'd be 60 up there. Hope I'm not getting that one wrong. Use your calculator. I want to make mistakes as a learning experience, but you should use your calculator for even the silliest things on test day. 60 degrees, so that means that we have sine of 60 divided by 240 equals, and then the length of the string, I'm going to just write as x right there. That's x now. And then that's going to be opposite 45, so sine of 45. So if I flip things around a little bit, actually I can literally flip this the way that it's written. So I can rewrite this as 240 over sine of 60 equals x over sine of 45. And then I can multiply sine of 45 times both sides. So sine of 45 over sine of 60 times 240 equals x. I'm just going to plug that in my calculator and we're good to go. So I know it's really messy for you all to see this, but I'm just going to try and do this as quickly as possible. So sine of 45, just square root of 2 over 2, divided by sine of 60, which is 1/2. No, square root of 3 over 2. So I use a calculator. All right, I hope that's right. Times 240 is 195 point something. Okay. Now, you might say, haha, Edward finally missed one. And I might have. But what I'm going to do is I'm going to look at A and B. And I'm going to say, all right, what's 60 times the square root of 3? It's not right. But what about 80 times the square root of 6? That is right. That answer right there is the same as the answer I got. So it would be B. Boom. Now, they probably wanted you to do the, the smart thing there of sine of 45 is square root of 2 over 2. So they probably wanted you to write that out as like, square root of 2 over 2 divided by square root of 3 over 2, hence the square root of 6. I could totally see, that right there ends up being square root of 6 over 4, I think, times 240. So 1/4 of 240 is 60. Is that, did we have 60? Was it 60 times square root of 6? No, 80 times square root of 6. Oops. I don't know what I'm doing there. I'm not worried about it. I got the problem right. Anyway, that'd be the smart thing to do, but pushing on. Don't gotta be smart. You just gotta be savvy. Alright, so what else be smart? If a publisher charges $15 for the first copy of a book, final problem. Yay. If a publisher charges $15 for the first copy of a book that is ordered and $12 for each additional copy, which of the following expressions represents the cost of Y books? They love to do this. What they're doing here is there's a y-intercept of 3. And the only reason I know this is because there's another test where they do the exact same thing, and I think it's the last question. And so many students miss this because they're like, oh yeah, it's something plus 15. But no, your y-intercept is not 15. your y-intercept is 3 because y equals 12x plus 3. The first copy, meaning x equals 1, should be 15. So 12 plus 3, which is 15. I know for a fact, immediately I recognize this. And that's just because I've seen so many problems. So I'm going to give a little speech at the end of this, but that's one of the things that I think is really important is practice, practice, practice. So 12x plus 3. Oh, whoops. The cost of y books. Oh, okay. So it's just x equals 12, y plus 3. They're just switching around the values. So it'd be f. If I'm wrong, let's talk about it. And I'm not. And that's it. Wow. That's a whole test that we've been through. It took 2 different live streams, but here we are, and I'm genuinely like thrilled. I think this is super cool. Anyway, that's it for today. So I hope that this was helpful. For anybody who has stuck around to the end, I really appreciate you sticking around. I hope that you got a lot out of this, especially if you attended both of these live streams. That's 60 problems that you've seen now in their entirety worked out by a math tutor. So I do want to, before I let you go, just say a few things about why we're doing this and the purpose of any thing that is not just sitting down and tutoring or sitting down and studying for a student. The reason why we're doing this is just to help students get a taste for the ACT. A lot of students have taken the PSAT in school or taken the SAT because that's sort of the default. But a lot of students, or a good number of students, do better on the ACT and they just don't know it until they've given it a shot. So the purpose of this stream is to give students an opportunity to look into the ACT and say, oh yeah, look, this is actually doable. Now, the other thing I want to say is, this by no means replaces tutoring. So I do hope that this is helpful for people, and I do hope that maybe they can, pick up some tricks, like that one really cool calculator trick. But, if you are serious about improving your score, you have to have a test plan. You could hire somebody like us to help you make that plan, or you can, try and figure it out yourself, talk to your guidance counselor. You have a lot of options, but you have to have a plan and you have to stick to it. You need to have a schedule so that you're studying regularly, and you have to know what material you need to be looking at. So one of the things that we offer totally free of charge, and you'll find it on this YouTube channel, is an ACT proctor, an SAT proctor too. So you can take the test at home free of charge. You can find tests online, or you can ask us to send you one and we will connect you to legal resources. And then you can use those to sit down and take a full test and see how you did. And, then from there we happily discuss your results with you. So, really what I want to say though is that a test plan is an important part of doing better. When you're at school, your teachers have lesson plans to structure your learning. You have to do that for yourself when it comes to test prep. Or you have to hire somebody else to help you with that step. If you found that it's difficult for you to sit down and be really thorough and diligent in your studying, that might be a good sign that it's time to hire a tutor. As you might have seen tonight, there's a lot of tricks and tips that somebody like myself who works with these tests day in and day out, there's some things that somebody like me just knows and can help you with. So that's another value, another thing of value that we bring to the table. But the big thing is you're not alone. There are a lot of really good resources online, and if you talk to your guidance counselor or reach out to us, we can definitely help you find some resources. That's it for today. So as I said, I really appreciate those of you who stuck through to the end, especially if you were here for the first stream and the second stream. But if you weren't, that's no big deal. I'm glad that people dipped in and dipped out and maybe got something out of this. So that's all for tonight, and I will definitely keep everybody posted through all the previous channels that we used of communication, if we do another one of these. So farewell.